when we analyze the time efficiency of the merge procedure, we can look at the pseudocode segment by segment. Okay, we have briefly mentioned that the merge procedure should take linear running time, which is big theta of n. Okay, and here n is the total number of elements in the output sequence, in the outputs array. So if we look at the pseudocode, and if we look at different parts here, the first 3 lines of code, they are for the initialization purpose. And basically, each line of them is a primitive statement. The first 2 lines is assignments, which should take a constant amount of time. And the third line is to allocate new memory space, which also takes constant amount of time. And here, from line 8 to line 11, they are all primitive assignment statements, which all take constant time. All right, so that's the constant amount of time taken care of. So what's left in the pseudocode are 3 segments of the for loops. Right, so there, from line 4 to line 5, there's a for loop, and line 6 to line 7, it is a very similar for loop. So when we consider the running time of a for loop, we need to basically primarily focus on the scope of the loop, the range of the loop iterations. So here, the for loop defines a starting point and an ending point. So for the first for loop, it iterates from 1 to n1, okay? And within each iteration, okay, so if within each iteration, there is just 1 statement, and this statement is a constant time primitive operation. So it's an assignment operation. So the statement alone in 1 iteration takes constant amount of time, okay? So that means there is no inner for loops or inner while loops like that. So it's easy to infer that, to know that the first for loop takes big theta of n1 amount of time. Okay, so the running time should primarily depend on the value of n1. So similar to the first for loop, the second for loop also takes linear running time, which can be written by big theta of n2. And together, these for loops takes that amount of time, n1 plus n2, which is n itself, okay? And let's focus on the last for loop now. So the range of the for loop is from P to R, which is the starting position and the ending position of the sequence, right? So the number of iterations is also n, okay? And within the body, within each iteration, the main body of the code is a if or else branches, okay? So in the if and else structure, only 1 branch will be executed. If the if branch is executed, there's 2 statements, right? Each of which is and both of them are a constant amount of time operation. And the else branch is also constant, okay? So no matter which branch is executed, so although here there are 2 lines of code and here there's 1 line of code, but this constant factor is not the determinant factor of a for loop algorithm, of a for loop structure, okay? We can ignore the difference between 2 and 1 here, okay? So the total amount of time is only dependent on the range of the for loop, which is n, okay? So consider all these different parts in the pseudocode. We can conclude that the merge procedure should take big theta of n time. Okay, so let's further interpret this big theta of time. So what does it mean? So that means the running time is a linear function. If the inputs has 100 elements, okay, then the total running time is about 100 times some constant c. And if we increase the inputs to 200, okay, then the running time is about 200 times c, which is 2 times the running time of the 100 sequence. Okay, so it's a linear growth. There's no quadratic growth. Okay. So that's it for the analysis of running time or time efficiency for the merge procedure.